All right, so we're going to color your periodic table today. We're going to go in order that you see up here. We're going to skip over hydrogen for now. We don't really talk about hydrogen. He's the orphan of the periodic table. He doesn't really belong to any family, but we're going to go down to the alkali metals. That's our first one. And I'm going to color them this pink. Your alkali metals go from lithium down to francium. So the way this is going to work, you're going to want to probably pause this video at times while you're coloring. Because I'm also going to put up some notes about each family that we talk about so that you can see some of their chemical properties and physical properties that they have in common. So the first family we're looking at are the alkali metals. Alkali metals, they only have one valence electron. They're also very reactive, like they react with the water that's in the air. They're very soft. You can cut them with a butter knife. You don't think of metals as being that soft, but it's actually how I prepare the metals when we do the demonstrations of these alkali metals reacting with water. They form metal hydroxides when they react with water. Things like sodium hydroxide you might have heard of before. It's a strong base. It's used in drain cleaners. And you don't see them freely in nature. They're so reactive that they don't stay by themselves. They get bonded very fast to whatever they're in. So the next family we're going to talk about are the alkaline earth metals. This is in group 2. So we did group 1, the alkali metals. Group 2 are the alkaline earth metals, and that is going to be everything from beryllium to radium. Alkaline earth metals are highly reactive as well, but they're not nearly as reactive as the alkali metals. So here's some interesting tidbits on the alkaline earth metals. All of them have 2 valence electrons. The alkali metals have 1, alkaline have 2. They're soft, but they're not as soft as the alkalis. They do also react with water, and they don't exist freely in nature, just like the alkaline metals. They react with water, and we have lots of water in our atmosphere. Next, we're going to get to the things that you think of as metals, the transition metals. It's the biggest block on our periodic table. It goes from group 3 all the way over to group 12. These are our transition metals. My purple marker is running out, so I'm not going to color them in all the way. But you should color them in. I highly recommend, if you haven't been using colored pencil, to use colored pencil. It works better so you can see in the information still. So, transition metals. We'll slide them up in a second. Your transition metals, they're the normal metals. They're what you think of as a metal. Things like gold and silver and copper and iron. They pool their valence electrons, which makes them really good conductors of heat and electricity. It's also why when we get to bonding in our next unit, you'll see these guys can pick and choose how many electrons they want to donate. They're malleable and ductile. All metals are malleable and ductile. Malleable means that we can pound them into a shape, and ductile means that we can stretch it into a wire. They can form multiple ions. They decide how many ever electrons they want to give up. And we'll talk more about how we figure out how many electrons they give up later when we cover bonding. All right. The next group of elements that we're going to be looking at, they are our basic metals. So, basic metals appear after the transition metals, and they're things like aluminum, gallium, indium, thallium, and all these newly discovered elements that have real names that just happen not to be on this periodic table. They kind of make a little staircase too. You'll see why they make a staircase in a little bit. So those are our basic metals. Basic metals are called basic metals because they only have one ion that they formed, unlike the transition metals that just have multiple ions that they can form. These guys will only form one charge. They have similar properties to the transition metals. They're still really good conductors of heat and electricity. They're malleable, they're ductile, and they donate electrons like all good metals do. So now that we've gone through metals, it's only right that we go to nonmetals. So, our nonmetals, things like carbon, nitrogen, oxygen, fluorine, not fluorine, I lied, not fluorine, phosphorus, sulfur, and selenium. These 6 elements are considered our nonmetals, our basic nonmetals. Nonmetals are the opposite of metals. They're dull, they're brittle, they're not malleable or ductile. Instead of donating electrons, they take electrons in compounds. They're not good conductors of heat or electricity, and most of the time they're gases, liquids, or soft solids. But most of the ones that you know of are gases or soft solids. Our next group are the metalloids. Metalloids, if you notice, there's a thick dark line going down on the right-hand side of the periodic table. It kind of forms a zigzag staircase. That's the metalloid line. Any element except for aluminum that touches that thick black line is considered a metalloid. So there's a little story about the metalloids that I like to tell. It helps me remember them. And it goes like this. One night, Mr. Plant had a little bit too much boron to drink. Boron's up here. He decided he needed one more glass of boron before he went to bed, but he was a little tipsy. So when he got to the top of the staircase to go downstairs and get his boron, he tripped and fell head over heels until he landed all the way down on his astatine. Now, astatine, don't color that in. If you notice, I haven't colored that in solid yet. I only want you to half color it in. Because astatine actually belongs to 2 groups. And same thing with this one down here, unseptium. It belongs to 2 groups as well. These 2 metalloids While they are metalloids, they're also part of another family that we're going to talk about next. But first, let me put up some information about the metalloids. Metalloids have properties of metals and nonmetals. So they have some conductivity, they have some malleability, but nowhere near as much as metals, and they're not nearly as brittle as nonmetals. Um, Metalloids are very important in technology. They make things like semiconductors, which are really, really important in your cell phone and in computers. Think Silicon Valley. Silicon is the best definition I can give you of a metalloid. All right, the next group that we're going to talk about, we're on group 17 now. Group 17 is the halogen group. So, and this is why we have colored these in. Because astatine and unseptium, which has a real name now, but I can't remember what it is off the top of my head, are both metalloids, but they're also part of the halogen group because they have a lot of the same properties in common. Halogens are all extremely reactive. They have 7 valence electrons. They're one away from that golden number of 8. So they're the most reactive nonmetals. They're all diatomic. They come in pairs when they're by themselves. You're never going to find a single fluorine atom by itself in nature. It's always going to be paired up with another one. Same with iodine. And the halogens have antimicrobial properties. You all heard of iodine before. You put iodine on to disinfect your cuts. But that's really not iodine. It's betadine. It's iodine with alcohol. Iodine, as you saw when we did the properties of elements lab, is actually a solid. So these are your halogens. Next, we have the noble gases. Noble gases are in group 18. The noble gases all have 8 valence electrons, which makes them very stable, except for helium. Helium only has 2. They don't react with anything. They're the model for chemical bonding. All elements try to get to 8 valence electrons. And you find them in things like neon signs, and you find them in insulators. Argon's pumped between window panes when you have double pane windows in your house because it's very good at conducting heat or keeping heat in and keeping cold out. We have 2 last families to look at. I'm going to repeat colors because I ran out of colors. So our next one is the lanthanides. And it's our first removed column down here. So the lanthanides are also known as the rare earth elements because they're not really found abundantly in nature. They're used in things like your smartphone, and they're used in catalytic converters in cars. And they're worth a lot of money because they're very rare. And then the last group that we have, all the way down here, are your actinoids. And they don't have much in common or much use. They're just all radioactive.